why security is no longer enough. I'm not sure about you, but I'm definitely excited what Anders Kjellberg will tell us about it. Anders, please welcome on the stage.
Thank you. So, also the tech is coming here. Okay, good. I didn't drown the computer. The presentation is working. My name is Anders. I'm Mobotics, Nordics, and the Baltics. On my side over there, I have Taylor Young in the booth. And the why is security no longer enough? A little bit of the background from Mobotics. This was how hardware looked in the past. It was hardware, more or less that. This is a little bit more the look and feel of the hardware, but the inside is a different story. We started in 1999, and not long after, Altas actually started cooperate with us. And there has been a lot of milestones. One of the big milestones was 2014, where we started with thermal technology. We have a wide range of cameras, but a few of them really put the focus on where we come up best with the combination of hardware and software. And there's a lot of talk about AI. AI is nothing new for us. It's embedded in our cameras since before I started 6 years back. And it will continue. But a little bit to tie into the theme here, what is this? Well, that was a previous driver of, let's say, security. It was hard security, very physical security. What it is today, it's more to protect heritage, wildlife protection, damage prevention, environmental aspects of the technology we have had for 25 years, and asset protection. It should be also life and health in this, but we'll come back to that. So value is a buying driver. Security is like how big is the security budget, but the value tied into certain aspects of that different departments with the budget can relate to. I would say prevention, and how do we protect those values? This slide is a little bit hard for you to read, but I just tried to nail it down to the different technologies and the different combinations of different sensors, and also IoT, and of course, how we combine that, let's say, data output from the technology, and how to absorb that into something actionable based on what we actually see as a protector of the value that we want to seek. We break it down to traditional video security, thermals, OCR, healthcare. So military technology that it's actually a social benefit as of today. We break it down to perimeter security that is quite traditional related to thermals, but also early fire detection and quality management. So if we see the Mobotics thermal technology, it's really a remote, it's actually, one of the cameras we have there is actually 300,200 pixels. So that's actually remote thermometers detecting, providing metrics for the system to take action on that data. So we can divide it in 20 different zones. I try not to be too technical here, but that really gives an enormous opportunity to measure different scenarios in the view of the camera. We have also added a few certifications that is related to fire protection, the different norms. In Europe, we typically lean into EM54. So we actually had our thermal cameras certified as a flame detector. but in reality, we detect the fire because there is any visual smoke or fire. But there was no norm for thermal cameras because we are unique in the world to actually have that on the technology. So, and also reduce false alarms because thermal technology is very quick and it's very sensitive to influx from the sun, from heat objects, etc. We'll get back to that. So health and safety, loss prevention, anti-litigation, tricky word, but it's really to see if a bus was damaged before it went into the depot and back. High value for the, let's say, the people who could say that this bus was hit by another car or in the depot. But to combine the solution, because there's a lot of money to invest in this technology, and we try to take out as much value for the investor. So here you can actually see how this camera is doing fire prevention at the same time as it stops copper theft, or me as a 13-year-old lad who actually went over the fence into recycling facilities because it was exciting, but I could risk my life. So here we actually stop fires, but also protect the asset for intrusion. Next slide. Here's a little bit how we do it, how we protect long areas. Now we're going to go into a little bit more examples, because what I said until now, it's really just theories, but these examples really shows how this makes a huge difference in typically Europe. So here is a solar farm, and that is high values, and they want to protect these enormous plants. This is a Spanish example. So they actually have 60 Modix M73 to cover this area. Next example here, a little bit of the background. Because if you see a thermal technology, it used to be, let's say, thermal temperature. But it was more or less just a contrast and something that detected the differences. But what we do today is really, we have every single pixels being a measurement tool for distances. We are talking hundreds of meters of distance where you can actually measure the temperature. Similar to what you do to yourself or to your kids to measure their skin temperature. But 300,000 something pixels. So go figure what you can do with the measurement of all those pixels in an environment. But as I said, it's really super sensitive. And what Mobotics have done really to filter out false alarm, because you don't want that. So we actually see what is the real fire, and we see moving objects that is typically one cause of false alarms. So excavators, forklifts, and so on. So we classify that as a moving object and should not raise alarm. Otherwise, it would be impossible to have this technology as a fire preventer. So we actually focus on what is the characteristics for a fire, and that is typically three things. The temperature rise. How quick is the temperature changing or actually declining? Because you could also secure a cold chain in a logistics center, for example. But has this point moved, and has it expanded? Is it the same size? Because if it's only 1 pixel or 4 pixels that is too hot, it's not considered a dangerous fire. So that is how we, in a very German way, breaking down to make it different, so to not create any false alarms. And we also have something that double checks this scenario, because if there is still a flame we can still say it could be a fire. So we don't take any risk of letting a fire occur. Some more examples: batteries, lithium-ion batteries, high density. That made the change for, let's say, a drone, how you could fly a drone. You couldn't do that from a battery 15 years ago, because, 20 years ago at least, because it didn't have the energy capacity to actually create a damage or fly a drone for 45 minutes. But these high energy batteries is really sneaking into everything we use, from phones to toys to Christmas cards. And they sneak into the waste management, recycling. It's basically everywhere. And it's really so much causing fires for all those plants who deal with any kind of waste. Here's an example, a few years back, but it really, and stay focused now, because this really shows the technology, what is happening with the camera, and how we divide it in the different zones, and how we can detect the fire on a very, very early stage. It's a little bit long. I don't have that much time, but I really want you to focus on this one. So if you see on the left side, the optical camera versus the thermal, you see more and more smoke. Of course, see the fire, but keep in mind it was detected before there was any visual fire or smoke. And now they start to take out the fire. And if you also see what is happening now, how the visual perspective of the thermals actually burns through the smoke, and later on also the moist from the water that is sprayed to the fire. I think this really, I showed it so many times because it really shows the technology, what we don't see, but what the thermal technology does. Okay, I think we've seen enough. We move forward. And this in practice, how can we deploy this to actually quicker? Because we can detect fire very quick, but how can we take out fire quick? So what we did, we cooperate with those who is actually good what we are not good at, and those who takes out fire. So one actually Swedish company, but we are dealing with other water cannon providers. So we can actually have two thermals point out where the fire is and have this water cannon put the water into that zone. Doesn't sound very complicated, but to combine all these interest, let's say, stakeholders in the different areas and actually do something really, really smart, that is, I would say, the dream scenario for me being, let's say, business development, but also product development. How can we solve a problem with smart combinations? Here it's actually another movie that shows this a little bit more in practice. This is an example site where they start different fires and have our thermals actually point in the robot to do that. Am I half through, basically, roughly? I didn't take the time. Okay, we'll continue until they stop me. But you see the fire, and this is a very, very clever way to combine. Here's an indoor example of the same, how thermal technology can point in water. I want one at home, but I can't fit it, and it might be a little bit too expensive. But this is really cool development of what we have worked with since, 11 years. Okay, Ecoservice, local example. They have deployed, they actually had a fire, 13.55 million euros. That's a lot of money, and that's not unique at all, because many sites scale up to be really productive. So if they have a fire, it's enormous amounts of money that goes up in smoke and flame, basically. So they deployed, and 16 M73s, one of the models we have, to reduce the fire and detect fires in early stage. There is more examples. Just to give you examples what areas we cover in a good way. So here is actually a thermal camera on a movable PT head that can detect or protect much larger areas. And once again, the battery, the whole lifespan of batteries is really crucial to protect and detect. So it's actually started with the Tesla Megapacks, and then it went into the next phase that is really to protect, let's say, charging stations. In this case, it's buses. We'll go back to that, and that's the movie we saw from the beginning. So, battery production. Here's one example. Here is one Swedish example with Scania, who is a truck producer going over to electric trucks. And every workstation, because the fire from lithium-ion batteries is really, really tough. It starts with smoke, and if you inhale that, you're really damaged. So every workstation, they have one of our thermals to protect the workers, because if there is a thermal runaway, they don't notice until it's too late. So here's actually the battery packs that is assembled and put into the trucks, and every workstation is then deployed by a thermal camera. So energy sector. Here is a mega pack from Tesla. And this is you see the little camera there that actually detects any heat change very, very early. Here's a little bit deeper insight in the Belgic bus project. Yeah, M73 again, really to monitor this area. And here is another, this is in the shipping. I had the opportunity to be a part of this ourselves. It's an enormous amount of shipping containers. Inside the shipping containers there is batteries. It could be 3,000 Samsung phones. And they experience a lot of fires, and the problem is to detect this early enough to take an action. So we went there, and this is quite amazing numbers. I didn't even know. The ship itself is close to 400 meters. It contains 18,270 containers. Enormous amount of value, but it's also enormous amount of risk. And we try by this to really be there. The risk is early. And this is one of those shipping containers. And enormous amounts, and we tried to find the perfect location to actually put the cameras to, with minimal budget, actually cover all the sides of the containers. It's a tough challenge, but we have chosen technology, and that's really, really fantastic insight. Yeah, I kept it here just to show the size of these containers. And keep in mind, 18,000 floating containers with a lot of batteries that just wait to take fire. So here we managed to find these locations. This is the same camera, but a little bit different form factor. Jumping over to a complete different example. Here is in Norway, Stavanger Hospital, where they use the same camera to protect our newborn child. So research tells that there's a lot of infants that is actually taking a hit from where they are born, and they really want to detect as early as possible the second the child is born, and also the temperature of the child's skin surface. And they invested in a lot of thermals, putting that into AI to really absorb, to iterate how they can make kids get a better start in life. So totally different project, very exciting. I had the pleasure to be involved. Jumping back to the more industry aspects, so here is what we call quality assurance. So not only fire, but also detect changes in the industry using the thermal spectra. So this is a cement production, and the wear and tear of components in this environment is really costly. So they use the same technology not only to stop fires, but also to detect changes where they can change that component to save costs. So that's another use case in that aspect. And this is kind of new to me, but this is really the optical sensor where you don't see much what is happening. But all of a sudden, if you get the thermal view of that and temperature, and start to create the process, what can I stop for damage related to this process? And then you can put that out in metrics and really actionable data. And that's where I started off to really see where Mobotics is heading and focus on what we have been very successful in. Here are some more examples. This is also from the Baltics to actually protect wildlife, or actually cars not hitting wildlife. So this is in the middle of the night. We wouldn't see anything. But if you can use the thermals to also protect the roads. Here is residential fire in bins. A little bit more deeper details about the Baltics example. Here is logistics. We don't see this, but every order you place is typically picked by those robots, put in bags and shipped to your location. These robots work in the ceiling of the packing centers, logistics centers. If they caught fire, it can be very damaging, of course, because there is no people there. Here's another example. Every tire we buy, there is a fee to actually collect the tires. I think that's the same in the Baltics. So 4 years ago, we started with Schrack Seconet, tremendous good company who is, I sound like Trump there, sorry about that, but it really taught me everything I know about fire and how they approach the tough conditions outside to actually detect fires. So they cut down the tires and use that in construction and so forth. And they deploy a lot of the cameras to see, because these rubber grains, it becomes very, very flammable if oxygen is added. And they don't want that to happen because they are very close to a major Swedish city. Here's another example together with Securitas Technology, where we did a very survey, and it's also related to the car industry, because in these packages that comes in, there is sometimes car batteries, and they don't know if they were damaged on the way to the center. So they really want to detect how soon can the thermal camera see through the box and the heat signature. So they simulated that. Successful project, and they moved on. Now they have a very procedure. They actually built a plant and how to protect from lithium-ion damages. So they deployed a big amount of cameras for the same purpose. Integration. We have small cameras that can be integrated into various machineries. Here is the Wolf. This is actually a extinguishing robot that has the thermal on top of it. Pretty cool things as well. Here's from high pressure die casting, where they actually used AI to detect the quality of the car parts. So they have our thermals to actually work as an X-ray of the components that they press, instead of realizing that it was a faulty process. They can do that with AI very early. Another cool project, I will move on here. Gas turbines, instead of flame detectors, they're using one thermal to detect all these hot parts to prevent the power plants to take fire. That happens too often, to be honest. And storage, solar parks. EU push all European countries to add more solar parks. We can debate if that's efficient or not, if there is a return of investment for solar panels. But there is a push, gradually push. So all commercial buildings need to have solar parks or solar panels on the roofs. But the insurance company says, hey, come on, you can't do that. I mean, that changed the whole structure of the building. But it's also causing fire. Actually, birds is one of the causes of these fires. So we came up with a concept to actually detect this scenario very early. So we place our cameras and detect abnormalities in the solar panels, because there is a lot of circuits, and typically they promise 25 years lifespan. I mean, imagine taking an electronic component and putting it outside, and that will wear down, and that will eventually cause fires. So EU is pushing for something that actually creates a problem. And of course, we use our capabilities to stop that. And that's not uncommon at all with fires in these scenarios. And the fire departments, they don't even go up there, because it's high voltage. The roof can break down because there is extra load from the panels. So this is our approach. Are we getting close? Do I have 30 seconds? Okay, I cannot forget all the other cameras we have. We have the whole range of different cameras, but I don't want to put focus on that, but really to nail what we make, where we stand out to be very unique. I didn't realize this was so long. Jumping over. Critical infrastructure, that's the last or last piece of my presentation or focus area. Critical infrastructure is very wide. But also OCR that ties into that. That is how we read text with cameras. I spoke with the new CEO of Altas, who actually comes from that industry and already have that thinking, and that's very refreshing. Proceed. Another Altas fantastic project, how to warehouse management. They actually measure, they both use cameras, but they also measure the weight of the pallets to see if there was someone stolen bottles of vodka typically. Nurse assist, fall detection I'm all over the place, but this is really what we do. We also do fall detection system for elderly care, hospitals, and so forth. We are less people having to take care of a bigger, older population. And this is enormous challenge, I would say. And technology in the hospitals, do we want that? But if the nurse can actually sit down with Agda, 83, instead of being afraid that someone is laying on the floor with a broken hip, that is where technology can actually make a fantastic difference. We can tell more about that in the booth. I think they want me down the stage, so I will just run this very to the end. And there's also metrics. How is the sleep quality? When do we want to disturb and not disturb the elderly in the elderly care centers? So this is actually technology really smart and created to serve the human population with sometimes AI when it's needed, but also avoiding the danger with AI, keeping it inside the technology. And most important today, I would say, it's made in Europe. Germany, yes, but that's Europe. So that's an important aspect for me. Thank you so much. Welcome to the booth.